Hello explorers and welcome to another video. Today we are going to tackle day 21 of Advent of Code. So let's just jump right into it. Dariak die. There is not much to do as you slowly descend to the bottom of the ocean and the submarine computer challenge you to a nice game of Dariak dice. The game consists of a single die, 2 pawns, and a game board with a circular track containing spaces marked 1 to 10 clockwise. Each player is has a starting space chosen randomly, your puzzle input. Player 1 goes first. Player takes turn moving. On each player's turn, the player rolls a dice 3 times and adds up the result. Then the player moves their pawn times forward around the track, and that is moving clockwise on spaces in order to increase the value, wrapping back to 1 after 10. So if a player is on space 7, they roll 2 to 1, they move forward 5 times to spaces 5, 9, 8, 9, 10, 1, and finally stopping at 2. After each player moves, they increase their score by the value the space their pawn stopped on. Players' scores start at 0, so if the first player starts on space 7 and rolls a total of 5, they would stop on space 2 and add 2 to their score for a total of 2. The game immediately ends as a win for the player whose score reaches at least 1,000. Since the first game is a practice game, the submarine opens a compartment labeled deterministic dice, and 100-sided dice fall out. This die always rolls 1 first, then 2, then 3, and so on up to 100, after which it starts over at 1 again. Using this die, for example, given these starting positions, 4 and 8. And the game would go 1, 2, 3, moves 10, total score of 10. Moves to space 10, total score of 10. Yeah, so goes from 4 to 10, yeah. And then 4, 6, 5 goes to space 3, and so score 3, and so on. And then they take the losing player's points and times that the total amount of times the dice has been rolled, which in this time was 993 times. Play a practice game using the deterministic 100-sided die. The moment either player wins, what do you get if you multiply the score of the losing player with the number of times the die was rolled? And I'm going to implement this with a bunch of classes. Might be overkill, might turn out being something that will be harder when we go to part 2 here. But I don't know. Let's do it like this. I have 2 players. I will have a die class, and the die class, I give the die class to the players in order to increase their position, and I will use modulus in order to choose placement from 0 to 9 and then add 1 each time I add on the score. Check when the player has actually won, and if a player has won, then I will stop the game and count up the loser's score. And I will make them take turns in some way. So that is what I will implement, and I will get back to you. And we are back, and we have already implemented something here, and I pretty much have this die up here, and then I have 2 players, and then I have the other 2 players, because in the example we had position 4 and 8, and in the real run we have 8 and 9, and I have this player has 1, which I flip back and forth. So they take turns each time. And then I have which player's turn it is. and then I check if either player 1 or player 2 has won. And if so, I will check if player 1 has won, I will take player 2's score. Otherwise, I will take player 1's score and times it with a die. And taking a turn is pretty much having this position where I am. So the player position is -1 because I will want to have a position from 0 to 9, so I can actually use modulus. And then I will roll the die 3 times, and I get a score back after this roll. And I add that to position, I will modulus with 10, and I will add to the score +1, because I have 0 to 9. And if the score is above 1,000, he has won, and he or she has won, and then I will return the score here. So that's pretty much it. And I also have a 2 strings, so I can see where the player is if I want to debug it. The die function, very simple. What is the next number I want? How many rolls have I done? When I want a new number, I add to the rolls. I check if the next number is over 1,000, then I will start at 1 again. And then I give me the next number an increment in one fill swoop there. And then I will do the roll, which is next. So very simple. And I can get a number of rolls. So I got this number here, 512,442. So let's see if that is the right number. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. Let's see what part 2 entails. Now that you have warmed up, it's time to play a real game. The second compartment opens, and this time a labeled Derek dice falls out a single 3-sided die. As you experiment with the die, you feel a little strange. An informal brochure in the compartment explains that this is a quantum die. When you roll it, the universe splits into multiple copies, 1 copy for each possible outcome of the die. In this case, rolling the die always splits the universe in 3 copies. 1 where the outcome roll is 1, 1 where the outcome roll is 2, and 1 where the outcome roll is 3. The game is played the same as before, although you prevent things from getting too far out of hand. The game now ends when either player scores reaches at least 21. Using the same starting position as in the example above, player 1 wins in that many universes, while player 2 merely wins in that many universes. Using the given starting positions, determine every possible outcome. Find the player that wins in the more universes. How many universes does that player win in? Okay. Every possible universe, there is a roll of 1, 2, or 3. And we need to figure out which universe and how many wins there are in each of them. And we are having the same puzzle input. One where the outcome of the roll has 1, and one where it has 2, and one where it has 3. Yeah, I will think about this and get back to you if I find a solution. Well, I'm back and I'm stumped. So part 2 was a bit much. I guess this is one of those, if you know how to solve it, you take a napkin, you write down the actual formula for this, and then out pops an answer. But doing this is in a pragmatic way, well, that's hard. So I have this quantum die here, I had some results up here, and I tried to fill it with some numbers. I tried a bunch of different things with this, so I could actually have adding to the number and then having it loop around, so I could have from 3 to 9, which is all the possibilities for 3 rolls. So I just could return that. Then I tried to do it with random, just to see if I could figure out a good middle ground, how much in percentage there were in difference between them, and so on. So I figured out that one of the runs with 2 of the numbers, it was 77% wins for P1, and on the other run it was 65 around there percent wins for P1. So I could have done some calculation there and had an approximate solution. It would not be to the actual specification that they are needing for this task, but I could have gotten it good enough for any other application. So yeah, I'm not really sure how to do this or how to get around this. So I think I will be beaten today when it comes to this. If I just come up with something, I will do an update video about that. If you have any suggestion, of course, leave them down in the comment section down below. If you like this video, give it a like, share it with your friends and colleagues, or give it a dislike if you don't like it. It's up to you. If you have any other more interesting comments than that, leave them down below. Or if you have implemented this in some way and have some good suggestions, leave that down below as well. And if you haven't subscribed yet, please do that. And I really hope to see you in the next video.